Saida, Milena, Diaz, Castillo, exploring UNet and LSTM networks for classification and segmentation of evolving granular structures. So please.
All right, so thank you so much for the nice presentation. Just want to mention that I'm doing this work with collaboration of the Andrés Asensio Ramos of the Instituto de Astrofísica de Canarias. And this work was made partially thanks for the mobility program SolarNet. So I want just to mention this fact. So what is the idea basically of this work? So I'm a PhD student currently, so I'm interested in study statistically the properties of magnetic field structure at the smaller scales that measure basically flux sheets emergency. So basically in quiet sun. So the idea of the work is to try to implement a classification and segmentation model that try to give us an idea of what types of what type of structure in the granulation we could have. So basically, during the last few years, this can be described that the extended structure in the quiet sun region, which is related to the granulation, can be having a specific morphology feature. So, for example, there exists exploring granules, which is basically a bright and rapid expanding granular cells that contain and explode in the core. So the idea is that we want to model or try to develop a model to try to look for rings morphologies inside of the maps. Or granular lanes, I just wanted to show you a movie that's changed a little bit and then explode. Also recently, it was found that there exists magnetic vortex structure that are like flux tubes that travel through granules that have also a specific signature in the morphology of the granules. It's like a wave that travels through the granule. And also the normal magnetic field accumulations in the, for example, in bright points, so in the intergranular region. So why it's important in my case is because I want to perform statistical studies that cannot consume a lot of time just looking by eye this type of structure. So with the new solar instrumentation, we're going to have a large amount of data, so in the end it will be easy for the researchers on this topic. So what is our initial intent? So initially we want to go to an easy way. So basically we make a model to segment morphological patterns in the granulation. We use initially a Granular data set, which comes from sunrise. This is a telescope that is localized in a balloon that flies during a week. Flights in 2009, I think that was the first slide. And the idea is that this data set is quite good in terms of not being affected for the atmospheric effects. So using this data, we use continuous intensity maps. We make the supervised approach, so we need to create the labeling of these morphological patterns. We initially segmentate granules, individual cells of granules, using a multi-level pattern recognition algorithms that is publicly available. Basically, they use a multi-thresholding procedure. They separate in equal spaced values of intensity threshold, and to try to do it in a way of top to bottom intensity. So probably we can take more time later to discuss how this method works. But basically, it produces the segmentation of every single granule. So I probably have in this, for example, in this map, around hundreds of different granules. And then by hand, I select the morphologies that I want to classify. So initially, the intergranular lanes, so like the patterns around. Uniform shaped granules. The idea is not granules that don't change too much in contrast in the cell. Granules with dots, like rings, and granules with lines, like things that can be similar to granular lanes. we use the unit architecture initially, and the initial test can be found in this paper already published. But basically, we have a problem, as many of us have with our data. We have a really imbalanced class in this. So the implementation of the processes, we generate a huge amount of submaps of small like patches of the complete field of view. We generate a data augmentation procedure, basically linear transformation. Anyways, we are going to have like 7% of this skew, and we try to test several loss functions to see what problems can appear to it. So basically, this is an example of one of the tests that we performed. In the poster, you can find more of those. But basically, I want to just summarize the confusion matrix that we produce that give us the maximum probability to match this category to the given original data. So the granules with dots, most of it, the best, gives the best results, more or less around 60% of precision. But the interesting part is how the metrics behaves with others in other cases. For example, how reliable is to determine one or the other class. And the other interesting thing is that the model itself, because it's fully connected, they don't care about the scales. So in general, I have the problem that overlapping the structure. So I have several features that belongs to the same granule. So I'm classifying like this, a unique cell, it's several times. So finally, the idea is to exploring the time dimension in this case. If you notice in the first slide, most of the features that I want to classify are identifiable, can be identifiable in the time domain. So it's natural to think that any recurrent neural network can be useful for detect this kind of behavior. So we test the long short-term memory models inside of the unit network. However, the process of training is giving me some problems. You notice that the training procedure behaves quite well. But when you go for the validation procedure, it's really gets not so good values compared with the single snapshot results. So the idea, but we have a hint that this is differential behavior in the training. It seems that I've just used initially the single init, but including the temporal evolution in the channels, just pass through directly through the channels. But if you include the LSTM there, you are going to have differences between the training procedure. So the idea is a future work that I'm currently developing. It's to produce and ground truth data focus on just a single class. Because if you started to mix several classes, I have the problem that I mentioned, that overlapping. So yes, basically the idea is to get at that. So yeah, this is that. Thank you so much for your attention.
Thanks. Questions, please? We have a question in the first row.
Hey, thanks for the talk. My question is, perhaps I got lost, but do you want to study this, how is the morphology of the granulation in time? That would be the idea, to see how it changed, or?
The idea is that this granular structure, they were already studied, and they were already identified with some morphological features, and are usually related to flux emergence. So the idea is to produce this automatic method with the idea that we already know how it looks, and to then perform a statistical analysis with other observables as polarimetric data, velocity, line of sight velocity maps to Doppelgrams, or of the idea of the velocity or transversal velocity maps, for example. So that it's correlated later. So first identify as a morphological structure and then correlate it with other observables.
Okay, perfect. Thanks.
Thank you. We have online question. Please, from your.
Yeah. Hey, Saida. Congrats. Very good job.
Thank you.
I have a question, and is how feasible do you think that this method can be applied to granulation at other scales? I'm particularly thinking on supergranulation. Do you have any idea of that?
What do you mean separate granulation? Because I have it here.
Well, yeah, when you have several of these granules that you see in your images, you can identify some supergranulation, which is basically the complete. Yep.
The problem.
And I can put this in context. I know some works with PSP and fields that are trying to connect their observations with supergranulation. I see also that your images are really high resolution images in a space. Could you, I'm going to complement the question, could you apply this technique to, say, HMI data, which has a low spatial resolution as the ones that you showed in here?
The good part of the unit architecture is, basically it's, because it's fully connected, in the end you can like put any kind of size of maps, and anyways you're going to try to look for the morphology itself independently of the scale, and that is my problem. It's going at really low scale, and I wanted to go at more bigger scale. So this is the idea about the resolution value. So if you reduce the resolution, probably you're not going to have a lot of tiny signatures or tiny features. So probably the method could work in that case. So yeah, let's try it.
Excited.
Any more questions? No. So,
Thank you so much.
Thank you.